Welcome to CollegeReadyMath's multiplication of radicals. In this lesson, we'll learn how to simplify radical terms and expressions that involve multiplication. Now, we've already learned one of the guidelines for simplifying radicals. We checked to make sure the radical had no perfect square factors in the radicand. If a radicand had a perfect square factor, we simplify the radical. 48, for example, has a perfect square factor. It's 16. The other factor is 3. Now, the square root of 16 is 4. The square root of 3 is already in simplest form. So the square root of 48 equals 4 times the square root of 3. There's no perfect square factor on the radicand. Now notice, there's only one radical in the simplified form. That's another guideline for simplifying radicals. So each term in a radical expression can have no more than one radical. Okay, look at this problem. We have one term with two radical factors, so we have to simplify. The square root of 5 times the square root of 7 equals the square root of 35. The square root of 35 has one radical with no perfect square factors in the radicand, so it's fully simplified. Now here's another multiplication example. The square root of 6 times the square root of 10. We have two radicals in one term again, so we'll multiply. The result is the square root of 60. Now we have one radical, but its radicand has a perfect square factor, so it needs to be simplified. The perfect square factor of 60 is 4, and the other factor is 15. The square root of 4 is 2, and the square root of 15 can't be simplified. So in its simplest form, the square root of 6 times the square root of 10 equals 2 times the square root of 15. Now the answer fits our two guidelines. There are no perfect square factors in the radicand, and the term has one radical. Notice that the simplest form has one rational number multiplied by the other one irrational number. We call this rational number the coefficient of the radical. 2 is the coefficient. The square root of 15 is the radical. Okay, now let's take a look at a slightly different kind of problem. Here we have two radicals, so we can start by multiplying them. But neither of the radicals is simplified, so we can also start by simplifying each of them. Now let's see what happens when we simplify first. The perfect square factor of 8 is 4, and the other factor is 2. The square root of 8 equals 2 times the square root of 2. 12 has a perfect square factor. It's 4. The other factor is 3. The square root of 12 equals 2 times the square root of 3. Now this isn't fully simplified. There are two radical factors, so we have to multiply them. There are also two coefficients. When we multiply factors like these, we have to be careful to multiply our coefficient only by another coefficient, and a radical only by another radical. So we'll multiply coefficients first. 2 times 2 is 4, and the square root of 2 times the square root of 3 is the square root of 6. The answer is 4 times the square root of 6. Okay, let's do this problem again, but this time we'll multiply the radicals first. The square root of 8 times the square root of 12 is the square root of 96. Now we'll see if 96 has any perfect square factors. Let's try 4. 96 divided by 4 is 24. So two factors of the radicand are 4 and 24. Now the square root of 4 is 2. 24 has a perfect square factor. It's 4. The other factor is 6. The square root of 4 is 2. Now we'll have to multiply it by the other coefficient, 2. The square root of 6 can't be simplified further. The answer is 4 times the square root of 6. That's the same answer we got when we simplified first. So whenever one of the radical factors in a multiplication problem can be simplified, you have a choice. You can simplify first, then multiply, or you can multiply first and then simplify. It doesn't matter, as long as the radical in the final answer is fully simplified. And that's it. You finished College Ready Math's multiplication of radicals.